Here is our star. We're given three key facts. Angles at A and B are equal, angles at E and C are equal, and the lengths of segments AC and BE are equal. Our mission is to prove that these two segments, AD and BD, are also equal. Solving this isn't just about getting the answer. It will help you master the power of congruent triangles, sharpen your logical proof-building skills, and ultimately see the elegant symmetry in complex shapes. Now, I want you to give it a try. Pause the video and think about these guiding questions. First, what triangles could you build using the given equal sides and angles? Second, how could proving two triangles are congruent help us prove our goal that AD equals BD? Don't worry if you're stuck, we'll solve it together right after this. Pause here and try to solve it yourself first. Need a nudge? Let's break it down. Hint 1. Look for a pair of triangles that contain our known equal sides, AC and BE. Got it? Hint 2. To prove them congruent, these triangles will also use the given equal angles. Hint 3. We need one more pair of equal angles. Look at the points that form straight lines. Remember, angles on a straight line are supplementary. Let's start our proof. The first step is to identify the key players. We'll focus on triangles ACG and BEF. Notice they contain our known equal sides, AC and BE. Now, let's prove these two triangles are congruent. We know side AC equals side BE, that's given. We also know that angle A is equal to angle B, and angles C and E are also equal, also given. Therefore, by the angle-angle side rule, triangles ACG and BEF are congruent. Because corresponding parts of congruent triangles are equal, we now know a crucial new fact. Segment AG equals segment BF. Now, let's shift our focus to a different triangle, GFD. Because we have congruent triangles, we know that angle AGC equals angle BFE. Now look at the angles adjacent to them, FGD and GFD. Since these are adjacent angles that form straight lines, and we just established two of the angles are equal, these two must also be equal. If two angles in a triangle are equal, then the sides opposite them are equal. So in triangle GFD, since the angles at F and G are equal, the sides GD and FD must be equal. Now for the grand final. Segment AD is made of AG plus GD. Segment BD is made of BF plus FD. We've proven that AG equals BF and that GD equals FD. Therefore, adding them together, AD must equal BD, and our proof is complete. That which was to be demonstrated, the hidden symmetry of the star, has been revealed. If you enjoyed unraveling this mathematical mystery with us, hit the like button and subscribe for more deep dives into math and science. Let us know in the comments what other puzzles we should explore next. Thanks for watching.